Today is chapter 11, week 5, and we're going to look at a few examples of problems in the chapter. The first problem is on page 606. It's problem number 9, and it deals with the fundamental counting principle. And a restaurant offers the following limited lunch menu. There are main courses, vegetables, beverages, and desserts. Now what you should note is how many of each. And let's list that. For the main course, there are 4 items. For the vegetable, there are 3 to select from. For a beverage, 4, and for dessert, 3 to select from. Now, what we'd like to do is compute the total number of possibilities for meals. And the fundamental counting principle would look at this as a 4-stage process where at each stage you're making a selection. And the number of choices is the number you're going to put in. So the total possible is simply a product. We have 4 mains to pick from, so I'll put a 4 there, times 3 vegetables to pick from, times 3, times 4 beverages, times 3 desserts. So when we multiply these together, there are 144 different possible meal combinations from that menu. Second problem we're going to look at is on page 614, problem number 13, and it deals with what is called factorial notation. Factorial notation in factorial is a product. 1 times 2 times 3 up to times n. For example, 3 factorial means 1 times 2 times 3, which is 6. The problem on page 614, number 13, is 9 factorial divided by 6 factorial. If we expand this, this is 9 times 8 times 7 times 6 factorial, because the rest of it is an indicated product. In the denominator, we also have 6 factorial. Now those are factors, 6, 5, 4, 3, 2, 1. Let me go one step further. 9, 8, 7, 6, 5, 4, 3, 2, 1. 6 factorial is 6, 5, 4, 3, 2, 1. And you'll notice all of these factors will cancel out. What's left is 9 times 8 times 7, which is 504. The next problem is also on page 614, and it is problem number 34, and it deals with evaluating permutations. Permutations are possible arrangements of objects. The formula and the symbol, this is read, permutations of n things taken r at a time. And the formula says that this is equal to n factorial over n minus r factorial. Problem 34, we're looking at permutations of 7 things taken 3 at a time. And according to our formula, this is 7 factorial over 7 minus 3 factorial, or 7 factorial over 4 factorial. Now, with what we did in the last problem, we know a lot of things are going to cancel out. This is 7 times 6 times 5 times 4 factorial over 4 factorial. And you notice 4 factorials, 4, 3, 2, 1, all cancel out. What's left is 7 times 6 times 5, and that is 210. A lot of scientific calculators will have permutations somewhere in the menu. Check your manual. You may be able to do problems of this type very simply on your calculator. Last problem we're going to look at deals with evaluating combinations. Combinations deals with making selections from some group, and the order doesn't matter. The symbol, this is read combinations of n things taken r at a time, and the formula is n factorial divided by n minus r factorial times r factorial. We're going to look at problem number 7 on page 619, which is combinations of 9 things taken 5 at a time. According to our formula then, 9 is n, 5 is r. This will be 9 factorial over 9 minus 5 factorial times 5 factorial, or 9 factorial over 4 factorial times 5 factorial. Now if we expand this a bit, we're going to have 9 times 8 times 7 times 6 times 5 factorial. 4 factorial is 4 times 3 times 2 times 1 times 5 factorial. Quite a lot of this will cancel out. Notably, the 5 factorials immediately cancel out. Also, you can have 3 into 9, and 2 times 4 is 8. You're left with a few numbers to multiply. 3 times 7 times 6, and that comes out to 126. Again, combinations is going to be on lots of scientific calculators, and you may be able to access that